In 2012, Jonas Zmuidzinas at Caltech published an amplifier designed to hear the Big Bang. The quantum computing world filed it under irrelevant. Current amplifiers read 4 to 8 qubits per signal line. This device could read 50 to 200 simultaneously. That gap may be the difference between a quantum computer that scales and one that doesn't. The technology is called a Kinetic Inductance Traveling Wave Parametric Amplifier on tantalum thin film. Zmuidzinas was losing sleep over noise. Every amplifier in his telescope buried the cosmic signals he was chasing. Meanwhile, quantum computing labs had a separate materials crisis. Qubits built on niobium were chemically chaotic at the surface, killing coherence times. A 2023 physical review. X paper by Crowley, McClellan, and Dutta mapped the loss mechanisms in tantalum microwave structures, giving engineers what researchers describe as the first real engineering blueprint for low-loss tantalum designs. Lab results show a KI-TWPA on tantalum delivering greater than 4 GHz of instantaneous bandwidth, 20 decibels of gain, and noise within half a quantum of the physical limit, though replication at commercial scale remains to be demonstrated. The catch: this sits at TRL 4 to 5. Lab demonstrated, not yet deployed at commercial scale. But Silent Waves, a French startup from Grenoble's Néel Institute, is already shipping early units. Global adjacent investment is estimated at $380 to $520 million annually, spanning DARPA, IARPA, EU Quantum Flagship, IBM, Google, and accelerating at roughly 25% year over year, according to analyst estimates. For a million qubit fault-tolerant machine, the cryogenic wiring bottleneck this technology aims to address represents a multi-billion-dollar problem, if the approach scales as current lab results suggest. By 2030, if fault-tolerant quantum computers scale as projected, pharmaceutical companies could potentially run molecular simulations that challenge classical supercomputers, though that outcome depends on hardware, software, and error correction advances beyond amplifiers alone. Whether the commercial inflection arrives in 2027 or 2029 depends on Fab P